Hey everybody, going with video number 2 here, so we're gonna keep working on getting better and better at it. Hopefully yesterday's or last class's video went okay for you. Today we're starting some new stuff. So unfortunately, not the best timing with us having to be out of class right now because this is kind of some heavier stuff we're getting into. This is a big chapter for us. We're gonna break it up. We're going to do a few days for each section so you guys have a chance to really get some practice in and trying these things out a couple different times. And some of it takes a little work. For the first section, it's just today. Pretty easy. It's very visual. We're going to talk today about starting our systems of equations. First thing that I want to touch on is what's a solution. We've spent quite a bit of time this year, as you guys know, solving equations. X plus 4 equals 12. Things like this, where we had you guys subtracting 4 from both sides, getting x equals 8 here. We had you guys solving bigger ones like this. 2x plus 5 would equal something like 25. We even had things going on where we had multiple steps involved, where we had you distributing first. 3x plus 2, 3 times x plus 2 minus 8 equals maybe even something like x plus 4, where you would have to do a whole bunch of work and get all these steps done to get that x by itself. Well, when we did all of that, we were focusing on finding a solution. What's a solution? A solution, hopefully we recall, that's that fancy term that we have for when we solve those equations. The solution is the value that makes the equation work, right? The solution to this equation was x equaling 8, right? I feel a sneeze coming on. Excuse me. Coughed into the elbow. Social distancing. There we go. So we found these solutions by solving for the missing variable. Now today, we're dealing with solutions with a system of equations. Okay, what's a system of equations? Sounds like something fancy. A system of equations is just when there's more than one equation happening at once. Okay, so whenever there's more than one equation. So what's happening is you've got these equations happening at the same time. Okay, you've got these equations happening at the same time. Notice that there's more than one variable involved. There's an x and there's a y. So what we're going to be doing in this chapter is finding the x value and the y value that make both of these equations work. I know it sounds like a lot going on in here, but let's look at it visually first. So this 2x plus 4y equals 8, and then the x minus 6y equals 12. Well, when we look at this already being graphed, I'm going to have to kind of move this a little bit because my face is in the way. When we look at this already being graphed, each of these is a line, right? When there's an x and a y involved, we've spent a lot of time talking about lines, and we really started with that y equals mx plus b. If there's an x and a y, it makes a line. So this red line is your red equation, and that's what we had over here, 2x plus 4y equals 8. And then the blue line is a separate equation of x minus 6y equals 12. That's what we had in the blue. So all along this line, it's full of tiny little points that go on forever and ever, and they're all points that belong on the line. For example, if we look at this point right here, 0, -2, okay, that's an x of 0, a y of -2. If I'm talking about the blue line, an x of 0 and a y of -2. If I plug the 0 in for x and the -2 in for y, since that's a point on that line, then that x and y value should make this equation work. It should be a solution for the equation. So if I plug in 0 for x and a -2 for y, back up here, a -2 for y, this should come out to equal 12. Well, 0 is just 0. -6 times a -2 is a positive 12. And then that 0 plus 12 equals 12. So when I took a point on that line, when I took this point that's on the blue line and plugged in the x and the y, it made that line work. That's called a solution. Okay? So now when we're talking about solutions to systems, we're looking for the one point that is going to work for both of these. We're looking for the one point that is going to work for both of these. Well, visually, what's the one point that you think would work for both of these equations? In other words, what's the one point that is on both of these lines? It's going to be where they intersect, right? It's going to be where they intersect, right here. So that ordered pair of 6, -1 is going to work for both of these lines. So let me just show you, and then the rest of this is going to be pretty visual. Okay, so 6, -1, we said, is the point that they share. 6, -1. If I plug in a 6 for the red one, for the x value, right, that's my x and my y, 2 times 6 plus 4 times -1 equals 8. That's going to be 12. 4 times -1 is -4 equals 8. 12 minus 4 is 8. Sweet. Now let's double check with the blue. 6 for x, kind of running out of room here, minus 6 times -1. Let's check to see if it equals 12. 6, and then -6 times -1 is +6. And what do you know? 6 plus 6 is 12. We get 12 equals 12. So since that point worked for both the red and the blue equation, we can now say that that ordered pair is the solution to this system of equations. So today it's going to be pretty visual for you. You are just looking at lines, 2 lines, and you got to tell me where they intersect. And wherever they intersect, that is the only point that they share, so that is their joined solution, 6, -1. So when we look at another one here, let me kind of skim over. -4 plus y equals 5, and 2x plus 3y equals 15. That's this graph. Where are these two intersecting? You look for that point that they share, and it's at the ordered pair 0, 5. So the solution for that system is the ordered pair 0, 5. You need an x and a y for this. 0, 5 is the one that works for both of these. And I could show you again, but I don't want this video to get too long. If you plug in a 0 for x and a 5 for y, it will make both of these equations work. One more. 7x plus 2y equals 1, and x minus y equals -5. I have another graph set up. Again, these two lines intersect somewhere. It's going to be right at this point, and that is the point -1, 4. That's the ordered pair, -1, 4. So the solution, again, is the ordered pair. Weird. It's glitching out on me here. -1, 4 is the ordered pair. That is the ordered pair that is the solution for that system. Okay, real quick, just so you guys can see it, there is another possibility here. You could end up with 2x plus 3y equals 8, and then something like, I think this is going to work, 2x plus 3y equals 10. Now, these are two lines, let's make them a little further apart. These are two lines that are what? They never touch, so they're parallel. Since they never touch, then there is no shared point. If there is no shared point, then they don't have a solution. So if we have parallel lines, then there's no solution. And you would visually see that because they would never touch. Parallel lines equal no solution. Okay? And then the last possibility that you could run into here is if you have the same line twice, 2x plus 3y equals 8 again. Notice the green line and the black line are right on top of each other. So they don't just share one point, they share all of their points. So if they're the same line, they share an infinite number of points, which means there's infinite solutions. So if the two lines are the same, then they have infinite solutions. Okay? And then the first thing we talked about was if they're going to intersect. So there are three possibilities here. They either intersect and they have that one solution, which is an ordered pair that we talked about. They're parallel, which means there are no solutions, or they're the same line, which means infinite solutions. Again, ran a little long. Sorry about that, but today's going to be really easy. This is really the intro to our systems of equations. Next couple of days, I'll probably only have one or two examples a day with the next two solution processes for solving these things. Today, very visual. Look at where those lines intersect, and we'll talk to you then. Have a good day.